Hello everybody and welcome. Today we're going to be programming a small network focusing mostly on SSH, NTP, Syslog and different usernames. So I've already programmed router 2, 3 and PCC. So let us work through the programming of router 1. As you can see, it's just been fully reloaded and it's sitting there at the setup prompt. So the first thing we do is we answer no to the setup question, give it a few seconds to sort itself out, and then we're going to program it based on the configuration map I showed you earlier. So the first thing we need to do is, whoops, wait for it, it's not completely ready yet, there we go. So we go configure terminal, hostname, router 1. We want to set up our enable secret, of course, because we have to have a good level of security, and we want to help us get around our typos if we make any typos. This is just to stop any DNS resolutions. So let us configure our interfaces. So, oops. Okay. Serial on this model router, the serial interface is a module and it takes a few seconds to load. So let us have a look, and I'm pretty sure it's not there yet. No. So we just have to wait one more minute for the serial interfaces to initialize. Oh, there we go. So just needed to wait another minute. So based on the diagram, our serial interface will be 10.1.1.1, 252 for us to /30. No shut. Whoops. And let us program the gigabit. 168.1.1. And we want a no shut on that as well. And this router also, we're using OSPF. I mean, we could have used RIB, but OSPF is definitely becoming a lot more popular of late. So actually, let's do one thing before we get much older. Let us go in and fix up that fact that the prompt is always getting in the way. So it's in line console and it's logging sync, short for logging synchronous. And that way, when we move in and out of commands, we don't have to get constantly, oops. Oh man. We don't have to get constantly interrupted by the prompt, keeping moving out of the way. So we've got two networks to advertise. The 192.168.1 network. And yes, with OSPF, when you program the mask, it's always as an inverse mask. It's a mirror image of a real mask. So if you think if you've got the mask of 252.252.50, then the mask is 00255. If you've got the mask of 252.252.252, then it's 0003. Just whatever the difference is to make you up between that 255. Now there's another, there we go, we've already formed a JSON with router 2. There's another useful command too, which is called passive interface. And what this means is that there is no other router on gigabit 0. So there's no point for OSPF to send broadcasts in that direction. It's just a waste. So we're going to enable passive interface on that. Alright, so there we go. We've set up a basic router with basic things. Now, let's start securing it and giving it a little bit more security. So first thing we're going to do is we're going to make sure that any and all passwords from now on have a minimum length. And we're going to say 10 characters. So now, if I want to try and reset the enable secret password and put in Cisco again, it's going to give us an error because that's too short. Now, there's also in your lab books and in the industry, there's actually a new mode of enable. There's this new type of super duper encryption called algorithm type, and then you've got three options: MD5, scrypt, or SHA. Now this router is a fairly new router, so it supports all of these extra commands. But you're going to find in the industry that there are still a lot of older routers and switches that you're dealing with, and maybe even older iOSs, newer routers with slightly older iOSs. So even though all your instructions say the most secure way to do it is enable algorithm script, I'm going to say no, just anywhere you see that algorithm script, just understand that it exists, but just go back to good old-fashioned secret, because that is still an MD5 hash. It's quite robust, but at least this way, if you template your commands, they're going to work on just about any device you come up against. And as you can see, I chose more than 10 characters, so therefore everything works. Now, we are going to go and set up our console password as well. So line console 0. Let's set the timeout. Let's be a bit more secure, so that if you're away from your desk for more than a few minutes, we'll set it to 5 minutes. So that if I'm not on the console of this device for more than 5 minutes, it's going to log me out. We're going to set a password of Cisco con pass. Pretty sure that's more than 10. Yes, it is. And we type the word login, and we've already typed logging synchronous so that those pesky errors get out of our way. So let's have a look at now of what we've done. So we'll do a show run, and we'll skip over all of the stuff at the beginning because we really care about. So we've programmed interfaces, good. We've got our OSPF, good. And this is what we've done. We've got exact timeout 5, password Cisco pass, logging synchronous, and login. However, something interesting has happened. Notice that password is in clear text, so we're going to fix that in a minute. So let's do a quick test, and let's see if we can actually remotely access this device. So I'll go over to PCC, because that's already configured. So first of all, let's ping it just to make sure that it works. 10.1.1.1, excellent. So let's try and telnet. NTP 1.1.1. Oh dear, password required but not set. So let's go back to R1 and let's fix that up. Oh, there it is there. See, nothing's in the line V2I. So we go configure terminal, line V2I 0 to 4. Now we have to set up a password. So we'll do Cisco VTY, PASS. Then we want to have, we'll put an exact timeout on that as well, just so that if it doesn't, if we move away from for too long, then it'll kick us out. That means you won't have any half-open telnet sessions for a long time. And we'll also lock it down so that only telnet works. So transport input telnet. Now we've locked it down, because if we do transport input question mark, you'll see there's a whole lot of protocols, but we don't want all of them to work. We just want telnet. So transport input telnet, and now we've locked it down. And of course we need the command login to actually activate the login. So let's go back to PCC again. There we go. So we type Cisco VTY P8SS, and we're good to go. And now I've logged into R1. So we type enable, Cisco 1, 2, 3, 4, 5, and now we're in enable mode, and we're good to go. So we've telnetted all the way from PCC all the way to router 1. But see, if we do a show run now, we go to the end, you notice those passwords are clear text. We can see everything that they're there. So let's fix that up, because we don't like that. And it's very simple. It's just service password encryption. Now this isn't as strong as the MD5 or the scrypt or the SHA, but it's a sort of an over-the-shoulder encryption. So it makes it a little bit harder for if anyone's walking past your desk and looking over your shoulder, they're not going to be seen. So now if I'm at work and I do a show run and I space to the end, then as you can see, it's going to be a lot more difficult for someone to look over my shoulder and try and memorize 05080F1C22434DO6171516016018. I don't know about you, but I can't memorize that quickly. So this is a service password encryption is always a very good thing to do. So we've verified telnet and we're good to go. Now something else we should try. Actually, let's exit out of this and we'll actually do it from the console. So I want to show you one other thing. Now, well, look and see, it's logged that we've done those things. What I want to look at now is more security. So make us better security. We need a banner. So good old message of the day. Go away. No access for you. Obviously, you should probably have a more professional banner than that, but I've just put a banner there just to prove that the banners work. Now, I want to show you the different usernames, because in a minute we're going to incorporate SSH, and we need to have usernames, because SSH needs 2 things. So we're going to make 3 usernames. Oops, username. So we're going to have Bob. He's going to have password. The password of, I'll just use classic silly password because that's easy for me to remember. We're going to make another username, Frank. Oops, need to learn how to type, Frank. And he is going to have, instead of the word password there, we're going to use the word secret. Because you'll see in a minute that secret does quite a different thing with the password. And finally, we're going to have Steve. Now Steve is really important. So we are going to actually elevate him with the privilege command. So that when he logs in, well, you'll see. Let's see what happens. Alright, so we've got 3 usernames. So let's end out and have a look at those usernames. And here's another command for you today. The pipe, if you're not using it, it's a lot of fun. It's just, for me, it's just over the enter key. So go show, run, pipe, and let's say include, and let's say username. So now when we do a show run, we're not going to get 3, 4, 5 pages of stuff that we don't care about. We're just going to get what is in that include. You can have begin, include, and exclude. Very useful commands when you've got a big, long running config. So we have username Bob, password 7, and that easy to decrypt hash. And you can go online and just Google, type 7 passwords. It's a very simple, like 20 lines of C code, and it'll decrypt it in the blink of an eye. But both of the secrets, they've got a 5 at the front. That means they've been encrypted with an MD5 hash. And that will take you months and months and years to hopefully brute force. So it's a much, much stronger level of password. So let's now go back to PCC, and we'll do our Telnet again. Oh, there you go. There's our, actually no, I forgot to do one thing. There's our banner work, at least our banner works. So what we're going to do now is we're going to go into our line BTY 0 to 4, and we're going to say login, and this time we're going to say local. So what this does is it redirects all the input into our telnets to use the local user database. So we have to use either Bob, Frank, or Steve. So let's have a look at how that works. So now when we telnet in, it says username. So if we type Frank and the password, my super duper secret password, now we're in. But notice there, we're logged into user mode. So we've logged in as user mode. Frank is logged in, and oh, that was who, just to show you who's logged in, and we're in user mode. But what happens if we log in as Steve? Because remember Steve, I added the privilege command at the very beginning because I've already pre-escalated that user up to that level. So that's a bit of fun. So Steve is logged in straight in privilege mode. He doesn't even have to know the enable password because his username. But Frank, when Frank logs in, he needs to know the username, the enable secret password in order to be logging in. So let's go back now and set up SSH. So we go back into configure. Actually, we should probably log out of this. Exit. There we go. Now I've logged out. All right. Now the first thing we need to do is create a domain because we're about to generate some keys, and it's as good as a self-signed certificate. So we absolutely need a domain. Now what options have we got? We want domain name, and let's call it networklunchbox.com.au. So there's our domain. We've created a name. Now, just in case someone else has been working in this router, it's often a good idea to make sure that there's no other keys there's no key originally in place. So there's this lovely command called 0eyes, and this will actually go through and say, are you sure you want to remove all evidence of other cryptology keys on here? So we say yes, and there it's done. So now there's no other leftover certificates. So let us create a certificate. We want crypto key. Now this command's got a few different, because you can do generate. Oh, sorry, I was one ahead of myself. This command's a bit interesting because you can do generate. You can do RSA here, Now you can do, here it is here. So you can do modulus, or you can do general keys. So depending on what you're trying to do, sometimes you can put the word modulus here, or sometimes you can use general keys. We like to put general keys here, and then modulus, and then give it a size, 1024, a nice big certificate. And there you go. It's took a few seconds, took less than a few seconds. Now note in particular too, the name of the key has been created. It is based on this. It's based on the domain name. So it's like a self-signed certificate that we've created with that domain name. Now it's also it's also SSH 1.99. Well, let's see if we can make it a bit better than that, because you can actually go to SSH version 2, which is a bit stronger. It's just a slightly different version. So newer clients have to work on all that sort of stuff. All right, let's have a look. Now, there's a useful command. We can check and make sure everything's right. Show IP SSH. And there's all the different things. So we've got a public key, we've got all our tokens, we've got all our commands. There's a lot of stuff going in there, but what you can see is we want HMAC, we want SHA for our algorithm, and our key is 1024 bits long. So let us try now. Oh, wait, hang on, we forgot one more thing. We have to go into line VTY 0 to 4, and now we want to change the transport from Telnet to SSH only. Because before we were allowing Telnet only, and now we're going to enable SSH only. So let's verify that. So what we'll do is we'll do show run. We'll use the pipe command again because that's much easier. We'll do section, because and then we'll just do VTY. What this is going to do is it's going to find that VTY and only show us the section. See how everything's out of space? That's a section. So the pipe command is really useful for limiting your output rather than just doing show run space 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 over and over again. So there you go. So we've got login local, transport input SSH. So we come back over to the PC. Telnet. Oh, Telnet doesn't work anymore. Well, that's no good. So we have to use PuTTY or some sort of SSH client. You can actually SSH from the router, but we'll do it, 10.1.1.1. Now, look, see, this is a pushback from PuTTY, a security warning saying this thing you're trying to get to has a self-signed certificate. Are you absolutely sure? And we just say yes. I mean, there is practice, or there is a precedent that if you wanted, you could actually go to all the trouble of buying a store-bought certificate and actually installing a certificate on the device. If you want it, oh, my banner's a bit broken there, never mind. There we go. So we logged in as Frank, and notice because we logged in as Frank, we still have to know the enable password. So we type enable and we put in the enable password. And now we're in. Everything's good to go. So that's SSH. Now the next thing we want to do is we want to set up the time. Now something interesting with the time is I've already gone in and I've set the time on R2. So let's have a look at the time on R1 and let's see what it's, oh dear. Well, obviously R1 definitely does not have the correct time. So let us set the time. And there's a couple of things we need to do to set the time. The first thing I like to do is set the time zone, because we are here in lovely Australia. So we need to set the time zone. And I'm in Australian Eastern Standard Time. And we are 10 hours ahead of Greenwich or UTC. So there we go. It's automatically set. It's moved the time from UTC to, you can see it there, from UTC to Australian Eastern Standard Time. Now something else, it's not necessary, but I'll just show you just for a bit of fun. We can actually set the daylight saving times as well. Daylight savings time. So it's recurring on the first Sunday in October at 2 AM, and it is the second half is the first. So that's when it starts, and it ends on the first Sunday in April. Oops, in April, NRL at 2 AM as well. No, I got it wrong. What have I done here? So, oh, October needs to be more. So what I've done is I've actually set daylight saving time so that it knows, and this is not necessary for today, but it's just a bit of fun, so you can actually set up daylight saving time. All right, now we have set up a time server on R2 and we've added a passphrase for security, because time on your network is critical, and if someone stuffs up the time, sending you bad time, that's really, really bad. So NTP is Network Time Protocol. We're going to set up the authentication key. So we want the authentication key, and it's an MD5 hash, and we've already set up on router 2 NTP password. So router 2 is actually, it's going to send out the time, or if we want to ask it for the time, we have to have that pre-shared key, otherwise we're not going to get it. So NTP, we need to say, look, you've got a couple of keys, but the key we want you to use is key number 1, because that's the key we just set. We're going to tell NTP that we have to authenticate, because it's using keys now. You can't just get time from anyone, because if someone injects bad time into your network, lots of bad things can happen. And the final thing is we have to say where we're getting the time from. So 10.1.1.2 is R2. That is the time source of where we're going to receive our time updates from. So we're now, right now, this guy's actively going out and asking router 2, please tell me what the time is. So let's verify that, and we'll do show NTP for Network Time Protocol, associations, there, and we can see it. So we have a peer, we have, it has a reference clock, it's detected as clock, it's local because it's just a local clock, and it's configured and it's running and it's good to go. So let's do show NTP status. And there's a whole lot of information about the clock. It's synchronized, it's referenced, and the time has fixed itself. So if we just actually did show clock now, you'll see that originally it was, March 1999, and now it's today's date and time, and it's even got the right time zone because I set the time zone ahead of time. All right, last but not least, we need to set up logging. So what I'm going to do is I'm going to go back to PCC, because I haven't set up PCA because I've been a bit lazy, but I've set up PCC. Now, there's lots of different Syslog servers out there, but thankfully, this guy who wrote TFTPD, he's actually included a Syslog server built into this software. So you don't have to do anything, and it's pretty much ready to go. So this is TFTP. We mostly use this software for TFTP, but it also has a really awesome TFTP built in as well. So let's go back to R1. And actually, why don't I do this via PuTTY, and you can actually see it happen? Because if we can have it actually happen in 2 screens in real time. That should be hopefully slightly. Oh, not you. Oh no, that's PuTTY still. I'm still here. Awesome. So let's go configure terminal again, and let us set up. Now, when we're doing Syslog, something else we want to do. It's optional, but it's actually really cool. Is we can set up the timestamps of our logs. Right now, they've got just the time since boot, but we want to actually have in there more information. So we're going to have time. We're going to have the time day stamp. We're even going to include milliseconds. It's going to be the local time, and we're going to have our time zone as well. So now anything that's logged on this device is going to have all that sort of stuff. Now what we'll do too, I just realized, is we need to, because we're using PuTTY, we need to see it in real time. Because when you're remote access, you don't normally see the console logs. But there's this extra super command called terminal monitor. So I've just enabled terminal monitoring so that any logs on the console will also be redirected to this PuTTY session as well. So we've turned on. Now we need to set up logging. Now, whoops, 2 Gs. Now different iOSs have different. You can use the word logging host, or you can just have the word logging. So whoops. So let's do logging host, and we want this IP address 192.168.3.3. So now, and there it is. There's the first log straight away, because we've started logging. Normally you have to say logging on, so I'll just type that in just for fun. But as you can see, in real time, you saw that the console, a message was generated, and it appears on our Syslog server instantly. And I was even going to go in to I'm going to do one thing. So let us just for fun go in and disable. Let's bring up interface 000 because it was down and now it's up again. So there you go, that's come up. Now notice here, it's a bit hard to see. I might make this a bit wider. So we've got the message itself, we've got the interface changed to down and then up, and who it's from, and the time date stamp. Obviously the time on this PC is wrong, but don't worry about that. Now notice too that we've got a link up down 3 and a link up down 5. Now we might say to ourselves, let's shut that back down because I'm gonna show you. Let's say to ourselves, you know what? We've got lots of errors, sorry, lots of notifications going on in our network, and some of them are 3s and some of them are 5s and some of them are 4s, and there's a big hierarchy, but it's messy. We don't want all that level. So what we're going to do now is we're going to actually say we're going to limit the amount of warnings that we're getting. See how we've got that number down here? We've got severity levels. Well, that's actually this number in the middle of all the warnings. So we're going to set this to 4 and below, which is just warnings. So now we only want warnings. So everything's still going to be logged to the console, but only the warnings are going to be sent to Syslog. So let's actually go back into interface gigabit 000 and bring it up again. And on my screen, you should see 2 messages, a 3 and a 5, but only actually sent to the server will be the 3. See, there's our 3s. Link 3 up down. It's a bit hard to, sorry. Look, there's the 3s, a bit hard to see, but the 5s weren't sent. So we'll do shut again. And see, those 5s weren't sent. And now if we exit out of global config, that's also a 5. It's just informational. So only the critical errors are now being sent. So there you have it. We've just done a very short lab. We've basic program of router 1. We have configured Telnet, then we configured usernames, then we configured SSH, then we configured time, and then we had a bit of a play with Syslog as well. So thanks very much for your time. Hope you enjoyed this video. Look forward to seeing you in the next one. Please remember to subscribe, hit that notification bell. If you liked what I did today, give me a thumbs up and leave me a comment with what you'd like to see in my next video. Thanks very much, and I'll see you in the next one.